Now, page number 18 is the identification of the ABC inventory system on step number 1. Number 2, it's the input into the cycle counting program. And 3, it is also the input into the inventory reduction program. And if you remember when we went through the ABC analysis, I indicated that 20% of your part numbers may represent 70 to 80% of your annual usage value. Now, the inventory can be reduced through vendor stocking by 70 to 80, if not more percentage-wise. But the key return is the elimination of the carrying cost associated with that inventory investment reduction. As an example, if you could reduce inventory investment by $100,000, you could eliminate the carrying cost on a recurring annual basis of $20,000 per year, assuming that the carrying cost is 20%. Fourthly, it's the input into a supplier lead time analysis, as we reviewed earlier. Fifth, input into a priority program. And sixth, it is the input into an obsolescence program. Now, item 7, I keep it on this list because people will ask me, Frank, can we set up a storeroom utilizing the ABC code? The answer is no, don't. Set up the storeroom using the commodity or family codes. That's the proper way to do it. Now, continuing on in page number 19 through 37, we're going to address the derivation of the different formulas that we had reviewed previously. And if you look at page number 19, we have the EOQ formula. And moving to page number 20, these are the data elements that identify the carrying costs. They are the insurance that we pay on our assets, the taxes that we pay on our assets, if we truly have an obsolescence program, the cost of capital, that is the cost to borrow money and any percentage points that are associated with that, and the cost of storage. Now, on a percentage basis, as I mentioned a moment ago, the carrying cost currently on an average basis is 20% per dollar per year, so that the carrying cost comprises these particular elements. So the key is to reduce inventory investment, and therefore you can reduce the carrying cost, as I explained a moment ago. Now, on page 21, we're looking at those costs that are an integral part of the purchase order costs. Now, these again are annual, and they pertain to the total expenditure for the purchasing department, the receiving department expenditures, the receiving inspection expenditures, and if any of the above 3 utilize, let's say, data processing applications, then those costs should be prorated back over the purchasing and the 2 receiving activities. Now, if I total all of those expenditures up on an annual basis and divide by the number of purchase orders that we're going to issue out over 1 year, I will be able to develop what we call the annual purchase order cost. Some people refer to it as the average PO cost, and others refer to it as the procurement cost, the cost to procure. Now, it's nice that we understand what goes in the carrying cost and what comprises the purchase order cost, but how are those costs actually used in the EOQ formula? So on page 22, we've got one illustration, and I think once we're through with this, you'll be in a better position to understand how the EOQ was developed and what the byproduct of the EOQ formula actually is providing us. So looking at the data that's on page 22, We start off on the top with annual usage value of $1,200. Similar annual usage value that was in our ABC analysis. S is the purchase order cost of $1, and I is the carrying cost of 10%. We're using these low figures to make it easy for both of us as we go through this particular analysis. Now, looking at the data in our particular exhibit here, and starting with the left-hand side, we're going to look at 5 different frequencies of ordering. And those frequencies of ordering are actually indicated by its numeric number on the third column from the right, called number orders. If we took that column, number of orders, and divided each one of those figures into the annual usage value of $1,200, we would get the second column from the left-hand side, OQ, and OQ means order quantity. So 2 into 1,200 is $600, and 4 into 1,200 is $300, and so on. So the second column from the left is the order quantity column based upon those 5 individual frequencies. Now, average inventory is equal to 1/2 the order quantity. So if I took the order quantity column and divided it by 2, I would get the average inventory, which is noted in the third column from the left. Again, if I took $600 and divided it by 2, I would have average inventory of $300 and so forth. Now, the carrying cost is defined as the carrying cost percent multiplied by the average inventory. So if I have a carrying cost of 10%, and remember, when we're using percentages in an equation, we convert that to its decimal equivalent. So if I multiply average inventory of $300 times 0.10, I would get the carrying cost of $30. And I would continue to do the same multiplication for the other 4 frequencies of ordering. The number of orders, again moving to the right, we've identified, and if I take that column, number of orders, and multiply that by $1 per order, I would get the purchasing cost column, which is the second column from the right. Now, the total column is the sum of the carrying cost column plus the purchase cost column. So if I have $30 for carrying cost in the first ordering scenario, which is semi-annually, and I add $2 of procurement cost to it, I get a total cost of $32. Now, you'll take a look at that right-hand column, and let's see what happens as we increase the frequency of purchasing. The total cost is starting to come down, and the reason for that is the average inventory is coming down, and its associated carrying cost for that average inventory is likewise coming down. But once we pass bi-monthly, you'll notice the total cost is starting to go up. We go from $16 up to $17, and then we get into semi-monthly, and we're up to $26.50. That tells us, in terms of the mathematics on page 22, that the most economical way to purchase this item would be bi-monthly. Now, we're not going to advocate that we're going to go through exercises like this for those part numbers that are candidates for EOQ. But what we want to do is find out how EOQ was derived. And the way EOQ was derived was to take the carrying cost column and the purchase cost column and the total cost column and actually graph those on one graphed document. So if you would turn the page to 23, we have what is called the total cost and its comparison to the number of orders. Now that's carrying cost compared to the number of orders. The number of orders is shown on the horizontal line, and the carrying cost is shown on the vertical line. Starting off at the extreme lower left-hand area of that graph, we have a straight line projecting to the right and upwards, and that line is called acquisition cost. Acquisition cost is the cost to acquire, and in this case that's the purchase order cost. Another acquisition cost, if the item was manufactured, would be the setup cost. Then we have that bottom line called maintenance cost. That's a geometric curve, and that comes from the right and it works its way down, it starts on the left, and works its way down to the right. And that maintenance cost, another term for that, is carrying cost. That is the cost to maintain inventory. Now, when we add the two costs together, as we did on page 22, which was the total right-hand column, we get the total cost curve, which is the total cost curve on this particular exhibit called total cost. Now, the development of the EOQ formula is as follows. The acquisition cost, that straight line, has an equation. The unknown in the equation is order quantity. The maintenance cost, that geometric curve, likewise has an equation, but the unknown is order quantity. If we set both equations equal to one another and solve for the order quantity, going through several iterations, we will actually get the equation for that total cost curve, and guess what? You're right, it's the EOQ formula. So you could see the EOQ formula was derived mathematically. It is a financial analysis of the following two data elements. It is comparing the cost to acquire to the cost to carry. Now, those two costs, the carrying cost and the purchase order cost that we looked at previously, were kind of the balancing scales. K1, carrying cost, the other is the purchase order cost. Where they're balanced, where they're equal to one another, that is the most economical order quantity. So it's a financial analysis comparing the cost to acquire versus the cost to carry. Now, moving on to page number 24, we're going to look at the development of the order point formula. And again, if you remember, the order point formula, or the ROP, reorder point formula, had two parts to it. First, it had some usage multiplied by the lead time. Well, in order to develop a true order point based upon many periods of usage, then in front of the word usage, I want you to write the word average, because we're really looking at several or many time periods during the lead time of the particular item. And that's where we get the term average usage. And then we're going to add to that product the safety factor times MAD. And if you remember, the safety factor came from a safety factor service level table, which we're going to look at in a moment. Now, turning to page 25, here is a graphic representation of an order point system. The order point up on top, if you were to put a dotted line from where all of those usage lines emanate from and go to the left to where you hit that vertical line, the first vertical line on the right-hand side, put a big dot there. That big dot is the point to order. It is a pre-calculated inventory level on hand, so that this left-hand vertical line is called bin on hand. And the bin on hand is the sum of the average usage plus the safety stock. And that really is the input into the cycle count formula. To get the average usage, each one of these lines would represent different usage periods. And we would, like we did in our previous order point example, we would add all of the usages by period together, and then we divide by the number of periods we're analyzing, and that would give us the average usage. And you also notice we have a lead time line which is horizontal. So if we take the average usage times the lead time, we would get the first half of that particular order point formula. And then we would add to that the safety stock portion. So moving forward to page number 26, this example illustrates the safety stock in the vertical column to the service percentage or service level on the horizontal column. And the curve is what is called the safety stock service level curve. And you could see by the values of service percentage or service level, they're synonymous, as we move from a low service level of 75% and moving forward to beyond 97.5%, you could see that that safety stock starts to rise exponentially. And incidentally, those lines at 100% service and that service level curve do not touch because they go up to infinity. The concept is, mathematically speaking, you can never have 100% of service on a consistent basis. So moving to page number 27, this is the table of safety factors for mean absolute deviation based upon a pre-selected service level. Now there's a couple comments I want to make before we go into some of the data on page 27, and that is as follows. The column on the right, it has a heading MAD, which is mean absolute deviation. That is not MAD. Those are the safety factors, as the heading indicates, for mean absolute deviation. If you remember from our previous illustrations on the reorder point in the example we went through, we had a service level of 95% for the item we were calculating the reorder point. If you go to the left-hand column under service level, read down to the 95% service level and read across, there you're going to find the safety factor of 2.06, and that's the exact safety factor we used in our illustration. So this is a table for service level, okay, for table of safety factors for normal distribution using the mean absolute deviation approach. Now, to try and pull the safety stock and the service level and mean absolute deviation and its associated safety factor together, on page number 28 is where we have developed, again working with many companies like yourself, the where used code and its represented service level and the safety factor for mean absolute deviation. So let's take a look at the left-hand column and let's address the where used code. Remember, if an item is used in 1, 2, or 3 different pieces of equipment or assets, then those 1, 2 to 3 where used codes are combined in this first line. Moving down, we have a where used code of 4 to 6, then we go 7 to 9, and then 10 to 12, and then greater than 12. If you were to go back to page 27, we have developed, again with companies like yourself, that if we have a where used code of 1 to 3, that we want to start off with a service level of 95%, and as we increase the where used code number, that numeric number, we're going to increase the service level. The reason for that, as we increase the service level, we're going to increase the safety stock. What's the rationale behind that? The higher the where used code, the numeric number, the higher the probability that there's going to be a stock out. And that's the key to the development of this particular analysis here. Now, you'll also note that there is a notation at the bottom of this exhibit. And I'd like to address what that notation is in some type of a scenario. Let's assume we have a piece of equipment and the OEM indicates that we should change the filtration media every 90 days on the basis of working one shift 5 days a week. So our frequency code for that PM would be every 90 days. It's what we call a fixed frequency. Now, let's assume that operations currently is working one shift 5 days a week. And if we continue performing that PM activity, hopefully, at least from that filtration media standpoint, we're not going to represent any problems relative to machine downtime. Now, operations goes to a 2-shift program. What should we do with that 90-day frequency code? It actually should be cut in half. That 90-day frequency should now go to a 45-day frequency. I have a question for you. When operations changes their mode of operation in terms of hours, do you change the frequency code in your PM program? Over 90% of the companies I've worked with had no idea that that should occur. And what happens is we start to recognize machine failures. And it's not because of poor design of the equipment or, let's say, the poor design of the spare part. It's because operations and maintenance management are not talking to each other. So it's extremely important if you set up some type of a where used matrix, as we have addressed on page 28, and it's set up on a fixed frequency. In other words, we're not using machine hours. We're using a fixed frequency code. You're going to have to adjust that frequency based upon the adjustment in the operations schedule. If you don't, like I said a moment ago, you're going to experience machine failure. Now, page number 29 and 30 go together, and that addresses the min-max system. And some of the derivation relative to the min-max is found on page 29. Let's walk through these. Item 1, the lead time must be immediate. Immediate is, to me, is anywhere from 1 day to about 1 week. Usage must be constant. Well, consistency, it depends upon the definition of consistency that we are going to use here. Let me give you a couple. I use an item every week. That's consistent. I use another item every month. That's consistent. As long as we have some consistency, some pattern, the min-max system will work. The minimum is the safety stock. Well, under a min-max system where the minimum is 0, then that means that the lead time is going to be 1 to 2 days. In other words, when I hit that minimum, I should have stock replenishment in a very short period of time. If, let's say, a supplier happens to be 100 miles or so away and I'm depending on, let's say, a truck carrier to replenish my inventory, then I may want to raise the minimum to maybe a 3 to 4 day average usage pattern so that I'll have some safety stock there to protect myself during that transportation period or the replenishment cycle, if you will, from the supplier. There are no formulas to develop the min. There are no formulas to develop the max. And there is a formula to develop the order quantity once the max and the minimums are established. So these levels must be looked at very subjectively, and the key is where is the supplier located, what is his or her inventory stocking policy, and what is the lead time between that supplier and the time I request a replenishment. If you turn to page 30, this gives you an indication of two different usage patterns that go below the minimum, and therefore we have to add D, the deviation to the minimum, which we had already discussed previously in this section. Now, page number 31 is the input into what we refer to as the bench stock or the free stock program, some people call it, and I've also referenced it as a two-bin system. The system is designed to support those inexpensive but repetitively used items in maintenance repair shops. In other words, what part numbers and quantity should we carry in a repair shop to eliminate the people in the repair shop moving to the, let's say, storeroom and filling out requisitions for those items. So this is something that should be established between the inventory management program, the storeroom, who will actually execute the program, and maintenance supervision. The outline starts on page 31, and let's see if we can, address these, and I'll amplify anything that I think needs further clarification. First of all, we have to determine the part numbers. And of course, associated with that, we want the description and we want the unit of measure. Then we want to develop, at step 2, what are the quantities that we want to carry in the repair shop? My answer to that question is somewhere between, let's say, a 15 to a 30-day supply. We want to establish the physical location, or locations if you have more than one repair shop, which is step 3. Step 4 is to establish the work in process physical locations, and that is within the repair shop. And then step 5 is to develop the requisitioning system to replenish that inventory, which is the responsibility, as I said, of the storeroom. Now, continuing on in page 32, we want to develop the inventory system to track usage. Every time we issue out, we record this, not only on the inventory storeroom record, but also in the inventory management record. We want to develop replenishment quantities. That would be up to the inventory management program, utilizing the inventory management ordering matrix. We want to track vendor lead times, again, just like the min-max system. We want to make certain our lead times are accurate. And then we want to revise the quantity that's going to be retained in the repair shop based upon the usage pattern. Now, if you would turn to page 33, this is what I referred to as the stock replenishment exhibit. This is for the mechanical shop, and as you can see on the left-hand top area, it's for roto bin number 5, tier number 5. Tier 1 is always on the bottom, so this is the 5th tier from the bottom. And around the periphery of the roto bin are the various part numbers that are identified on this document, their description, and also the quantity. So in this case, for these items, this company has elected to start off with 25 pieces of each one of the part numbers. Now, the way the system works is as follows. Periodically, maybe 2 or 3 times a week, the individual in the storeroom will take all of these replenishment documents with him or her, maybe on a clipboard, and physically eyeball the individual locations. And I said eyeball, and that's exactly what I mean. You don't have to have a scale and count the balance there. And if you feel that an item should be replenished, you merely place a check on the replacement column on the right-hand side. We could go into the storeroom. We could go into a manual inventory record. We could identify the bin location for this item. Now, if you have a fixed bin location, it could be added to this particular document. We could show that we're going to use 25, so we'll reduce that bin on hand by the 25, actually pick the material, bring it out to the mechanical shop in this case, and put it into the appropriate storage area. Now, that's in a manual environment. If I am utilizing data processing in the storeroom, all I have to do is to, again, manually go out into the shop, put a check mark next to the items that I want to replace, but rather than go into a tub card file, I'm now going to go through a terminal. I'm also going to indicate by part number the part numbers that I'm going to replenish. It has a fixed quantity because it's on this particular form. It automatically reduces the bin on hand, and therefore I would pick the material and I would replenish the repair shop inventory. Now, if you really want to automate this, you can replace this two-bin mechanical worksheet by using barcoding. I could barcode the labels that are out in the various repair shops by location, have a handheld wand. I go out there and merely read the barcode label. When I'm through, I could take that wand, put it into a port, maybe by a terminal. It will upload all of the data, and in the storeroom I would have a pick ticket printed out by part number, description, the quantity, the bin location where the material is located, and where it is to be delivered. Now, when I've done that uploading, it automatically is going to update the bin on hand. Now, in either case, manually using CMMS or using barcode to enhance CMMS, the inventory system is also being updated relative to the usage. So the two things that happen simultaneously is, one, the bin on hand gets reduced by the quantity picked. Secondly, the quantity picked is shown as usage on the inventory system, and that's how we track our usage. So you have an opportunity here to pick and choose any one of the three to get started, but ultimately my recommendation is to use barcoding. Now, the next exhibit shows us a decentralized location for a mini storeroom in a decentralized storeroom environment. The items that are in there are used primarily for the 4 operating departments that are shown on this exhibit, and there is a pre-printed document which is actually the pick ticket, which identifies by part number, description, unit of measure, the bin location within that storeroom, and all the maintenance person that is assigned, let's say, a planned or unplanned requirement goes into that area, gets the appropriate quantity as indicated on the maintenance work order, and then merely applies the quantity that he or she is removing from this decentralized storage bin. And then that pick ticket, if you will, is given to the storeroom, and they will update the disbursement against the appropriate maintenance work order. One last word of caution, like the main stock room, the satellite, or the decentralized storerooms, if you will, are all secure. And that's the key in order to make the system work. Now, we have another example on page number 35, which addresses the difference between the number of in a unit pack, the number packaged, I was going to say, in a unit pack, or the minimum order quantity. So I want to look at just some of the data that is on this exhibit, and then we're going to go through 2 scenarios, and then we're going to ask ourselves a very important question. Then I want you to make a notation on this page so that when we're working with purchasing, and this is another key indication of why we need full-time purchasing support in the maintenance management program. Under the first scenario, we're indicating that the requirement for 20 days is $17.95. So this undoubtedly is a planned requirement. The item record above given says that $2,000 is the vendor minimum. So in this case, we buy $2,000, and so we're going to have 205 pieces from that particular purchase lot in our storeroom. And don't forget, we do have an inventory class code for vendor minimums. Now, in the second scenario, and this is another 20-day horizon, we notice that there's 2,365. So the record says, well, 2,000 is the minimum, so we're going to issue a purchase order for 2,365. When the vendor receives the PO, they get on the phone and they call purchasing and say, purchasing, you made a mistake. You should have ordered 4,000. Now, here's the question that I want you to write below that second scenario. Is 2,000 the vendor minimum or the vendor unit pack? In this case, it is not the vendor minimum. It is the vendor unit pack. And this is a key responsibility of purchasing to support the difference between a vendor minimum and a vendor unit pack. And ironically enough, we're including in the next 2 pages the derivation of minimums and also unit packs. So on page 36, I'm outlining what a minimum is. Item 1 indicates that the minimum is established by the supplier. A minimum could also be a unit pack, but not necessarily, okay, if a unit pack is larger than the minimum. 3, it is purchasing's responsibility to determine from the supplier if the quantity is a minimum or a unit pack, as we just gone through on the previous exhibit. It is also the purchasing responsibility to convey this information to the inventory management function if the same person does not support inventory management and purchasing. Now, moving on to the supplier unit pack, page number 37, item 1 indicates that the unit pack is established by the supplier. Number 2, a unit pack indicates that there is X quantity in a package, drum, reel, or whatever that package quantity represents. 3, the purchasing system must have the capability to convert a unit pack to quantity per pack if you have smaller quantities in a particular master carton. The receiving function counts the number of packs received. The receiving function should spot check quantities in the smaller unit packs to make sure that the quantities are right. And when the material is placed in stores, the store system must have the capability to convert a unit package to actual quantity received in order to reflect the actual and accurate quantity that is going to represent bin on hand. So here again, we're tying in the inventory, the storeroom, and the purchasing system through these 2 applications. Now, starting off on page number 38 through 41, we have 4 pages that represents the outline, if you will, for a vendor stocking program. Now, if you remember, we discussed vendor stocking programs several times previously in this section, but here we want to go through the different steps, if you will, to provide you with the way a vendor stocking program should be addressed. First of all, step 1 indicates that we want to develop the part numbers. And again, in addition to part number, we want to have the description and the unit of measure. 2, we develop our estimated annual usage. And you could use the same data as a byproduct of your annual usage value, if you will, from an ABC analysis. But step 2 indicates that if you feel that changes are made to that annual usage, then please change it accordingly. Step 3 is calculate the actual cost for all items, and then you may want to select 2 suppliers for key items where the quantity may be large. And there is a note which indicates that more than 2 suppliers may not provide the volume of annual purchases to make the supplier stocking program a success. So again, on the other hand, if the volume isn't there, there is also a final sentence to the note that 1 supplier could prove risky. So again, what is the criticality of the item, what's the volume, and what's the delivery history of the supplier. And 5, you want to negotiate the benefits of the stocking program to both you and a supplier. And on page 41, I address those benefits, which I will review with you. Now, continuing on page number 39, step number 6 is establish your reordering criteria. And you know, many items that are part of a vendor stocking program can utilize the min-max system, because most suppliers, based upon the minimums that they're going to carry for you, should be able to pick and pack within a 24-hour period. The other application or timing that you have to consider is the transportation time from the supplier to your receipt into your maintenance storeroom. Item 7 is the delivery times, okay, for the items from the supplier. You want to establish the inventory levels that the supplier should retain for you as step 8. And then step number 9 is, if you're going to computerize your storeroom, you may want to commingle this directly to the supplier with a dial-up line, which would go directly from the storeroom to the supplier. You want to establish security codes so that you can have what we call a secure dial-up system. And then, as step number 11 indicates, you want to test the system, and then you want to implement the system, and then you want to make any adjustments or changes that will occur through monitoring, which is step 13, and then subsequently the changes on step number 14. Now, what I've just identified is where the supplier carries the inventory for you. He or she owns the inventory. If you have the inventory sent in and still under the supplier ownership, then you have probably tighter control over the inventory, and the only thing you have to consider is the lead time to replenish any of the supplier's inventory, which is your bin on hand, and that is called consignment in. So irrespective of whether the supplier has the material in his or her house, or whether it's in your house, the benefits as outlined in page 41 are the same. You want to eliminate interviewing sales personnel, which is really a benefit to the supplier. Eliminate generating purchase orders, which is a benefit to you. We're going to eliminate processing supplier quotations unless those are brand new items through the new item notice system. You're going to reduce purchase order processing cost, which is beneficial to you. You're also going to eliminate expediting suppliers, because once you dial up and bring the data on a terminal in your storeroom, you know specifically what the supplier has been on hand. That's when the supplier carries the inventory. The key is to reduce your inventory carrying cost and subsequently reduce storage cost. There are undoubtedly additional benefits to both you and the supplier, but this should be what I call a win-win situation for both the supplier and yourself. And last but not least in this section, we have 4 pages starting on page 42 to page 45, which addresses the elements in a JIT program. Now, these elements are what I call the key requirements to support JIT and maintenance management. If any of these elements are not in place 100%, then my advice is to get those fixed, get them into a position that they are reliable, and therefore you will have an excellent JIT program within the maintenance management program. Now remember, all items in your storeroom cannot be supported by JIT. I'll give you one illustration. Let's say I need a couple grommets or O-rings or a few plates, end plates, for a particular application. I'm not going to buy grommets or O-rings or end plates 1 or 2 at a time, depending on the quantity required to support a PM. So those types of items will probably still be managed under maybe an economic order quantity, or they may be an automatic byproduct of a vendor minimum or a vendor unit pack. I'm basically talking about the high dollar items that when you need the material from the supplier, the material can be shipped in a very short period of time, like maybe within 4 hours or less, maybe within a day or less, but certainly not beyond those time periods. So let's take a look at some of the key data elements relative to supporting JIT. Number 1, the asset spare parts list is complete and accurate. It's supposed to be complete and accurate without JIT. Number 2, the spare parts where used list is complete and accurate. 3, the total lead times for all JIT items is defined and accurate. 4, the suppliers have a thorough understanding of their requirements and how they support your JIT program. 5, supplier quality problems do not exist. Well, how did you get to that point? By instituting a vendor verification program. Number 3, a supplier shipping quantities are 100% accurate. Now continuing on to page 43, item 7, supplier delivery dates are 100% on time. Item 8, the maintenance work order scheduling system is scheduling both planned and unplanned maintenance work orders. Remember I said earlier, you can plan and schedule planned maintenance work orders. You may not be able to plan the unplanned work orders, but you could probably schedule those, and that's what I'm alluding to in item number 8. 9, the maintenance inventory control system is recording both planned and unplanned requirements. 10, special tools and equipment for the maintenance work order are known and available. 11, maintenance craft requirements are known and available. And continuing on to page 44, 12, the maintenance storeroom crib has a defined area to house unplanned maintenance work orders. They don't get commingled in with the JIT program. 13, the maintenance work order scheduling system is interfaced with the manufacturing work order scheduling system and the maintenance purchase order system. In other words, if we're doing this, we are in what I called in section number 1 of the notebook, if you will, at the beginning, a world-class environment. Item 14 is the equipment asset will be available as scheduled by the maintenance work order. And without 13, there are times that the work order is going to have to be rescheduled. Therefore, I'm not going to meet step number 14. Item 15, the maintenance work order reporting system is accurate and timely, which means I'm getting my observations and findings and recommendations for operating improvement from my craft personnel. And 16, changes can be made to the JIT schedule from plan to completion with ease. In other words, there's no critical issues involved. And continuing to page 45, step 17 is the maintenance JIT program has top management total support. And the last item, 18, indicates that the maintenance management and manufacturing management groups have both contributed to the design, the training, and implementation of the maintenance JIT program. There are some companies that are doing a successful JIT implementation in maintenance. In fact, there have been many articles addressing those companies that are in this particular area. The key to the success of JIT is the planning and scheduling system must be in place, and that the data elements, as I've indicated in these last 4 pages, must likewise be in place. If you follow the data elements in this section, section number 4, and study the various applications, the inventory management techniques, and the ordering matrix, the inventory management ordering matrix, I will guarantee that your inventory will be reduced. I'll also guarantee that you will be saving inventory carrying cost. And that carrying cost can be used to support maybe a CMMS system. It could support maybe second and third shift support of the storeroom or other personnel as your system starts to expand and the company starts to add on additional assets that are going to be managed by maintenance. Now, what we want to do is move into section number 5, which is the purchasing management section relative to supporting purchasing in the maintenance management environment. Starting off with page 1 in section 5, which is the purchasing section of this seminar, we want to address some of the data elements that should be considered in order to establish the data requirements and the way the purchasing function will support the maintenance management program. Starting off with item number A, we have our spare parts part number. B is the description, and C is the unit of measure. And item number D are the purchase costs. Now, that can be singular if we only have one supplier, or plural where we have 2 or more. We also have the lead times under E, and again, it could be a 1 lead time for 1 supplier or multiple lead times if we have more than 1 supplier. Then item F indicates all of the supplier information. And there's a myriad of data that would go into that particular record unto itself. G are any open purchase orders, and that would not only be by purchase order number, but likewise by supplier. The same would hold true for item H, open purchase requisitions, and then where supplier stocking programs or program exists, that would be by supplier, item number I, and J would be corporate procurement programs where 2 or more facilities are purchasing the same item from the same source namely the supplier. Now, in order to make corporate procurement programs work properly, the 2 or more facilities would have to have the same spare part or item part number. And K would be the development of a supplier performance program or programs, and that would lead into supplier evaluation and ultimately certification, which is one of the key data elements into supporting JIT. And again, if there is any additional overall data that should be incorporated into the purchasing database file, then please add that information accordingly. Now, moving on to page number 2, we have a very comprehensive list of some of the key purchasing functions that the purchasing department needs in order to support the maintenance management program. Some of these would have to have, let's say, support and direction from people outside of the maintenance department, and when we get to those items, I'll make reference to them. First of all, we need supplier selection. Now here again, the purchasing person or personnel supporting purchasing should not by themselves select suppliers. They should also have the input of the maintenance supervisors, likewise maybe maintenance craft personnel, and also facilities engineering if facilities engineering is an integral part of your particular requirement. Supplier analysis really pertains to the delivery performance of the supplier, his or her pricing structure, the quality of the products, and any other analysis relative to the ranking of the supplier where you have 2 or more suppliers that can supply the same item. The issue purchase orders is a very, key requirement, but over and above issuing the purchase orders is the follow-up, and this is the one element that really is a negative impact to maintenance work order planning and scheduling. Another function would be obtain quotations, get into some price negotiation, not now pricing debates, but price negotiation where you've done a market research and you'd like to buy from supplier A, but supplier B has a lower price, and here's where you would like to negotiate with supplier A to try and get the same price as supplier B. There's market analysis to be made, and that is those applications that are innovative by particular suppliers. I can cite just 2 basic areas. Most recently, there's been an insurgence of the design and manufacture of motors that operate with less horsepower, providing the same type of requirement for that particular motor application. Another one is in the field of luminaries, where we are now able to install lumens that provide us more operating time than previously. Those are some of the key requirements and byproducts of market analysis. Purchase price analysis is done at the time of quotation. Tracing supplier shipments may seem mundane, but it's very important to maintain the integrity of the maintenance work order and planning system. Then there is the disposition, if you will, of surplus or the fall off or revert material that we discussed earlier in section number 4, and that is how can I properly make certain that any of our material that is either obsolete or potential scrap not find its way into the marketplace. The answer to that question is use a bonded scrap dealer. The bonded scrap dealer will provide you with the documentation that would certify that that material is either going to be smelted down, if that's practical, or it may find its way into a bonded landfill program. There's always a need to continue to look for alternate suppliers, and here you would undoubtedly require maintenance management support and also facilities engineering if you have facility engineering capability. Verifying the quality and the quantity is really an integral part of the storeroom's receiving and receipt inspection function. But here, purchasing has a dotted line authority to that receiving function to make certain that all receipts are verified relative to quantity, and those items that are part of receiving inspection are actually going through the inspection function. If, on the other hand, items should be inspected by a third party, let's say an outside inspection contractor, then that should be an integral part of the purchasing responsibility, and that outside inspection lead time should be added to the aggregate lead time of that item and should be noted in the inventory management program. There is the need to review and approve invoices. That's a normal process of the purchasing function. And the next two is where I feel we should ask for outside assistance, and that is establishing penalty clauses or legal aspects of any type of a contract. Here, you should have top management support guided by, let's say, house counsel. The issue of delivery and shipping instructions is a byproduct of the way we want to ship and how we want to have it packaged. And here again, the purchasing department should have dotted line responsibility to the storeroom. And issue, billing, and terms is really the input from financial management to purchasing, and the various reports that management may want from purchasing. The easiest way to get that is to ask the management not only of, let's say, the maintenance operation, but let's say facilities engineering, operations, finance, and the chief executive officer. What would they like to see come out of the purchasing function that is supporting maintenance management? And you can therefore develop the data elements that are required for a specific report, but make certain that those data elements are in the purchasing function within the maintenance management program. Now, I have two exhibits here that are on pages 3 and 4, which are really a requirement when you're considering selecting a supplier for spare parts. Now, I'm not talking about hardware items and standard electrical and plumbing shop supply items. I'm talking about items that are of a critical nature, and the purchasing people have to get some internal education so that they can talk intelligently to either current or future suppliers. So some of the data elements would be as follows. Item 1, the uniqueness of the spare part. Second, what are the unique operational features of a spare part? Now here again, we're not advocating that purchasing is let's say a design engineer, but is trying to get data relative to sitting down when we discuss these types of data elements with current and future suppliers. How many suppliers are there? And again, what is the ranking and the rating of the suppliers relative to each other's performance? Which supplier has the best quality, which supplier has the longest operational lifespan. See, these are data elements that should be known by purchasing within the maintenance management program. Which supplier has the best delivery record? Are there alternate products? Well, that is like a substitute, but purchasing can't go out and recommend substitutes by itself. It has to be supported by maintenance management, maybe facilities engineering, or even the OEM of the equipment or the particular asset. Continuing on page number 4, item 8 pertains to the operating history of any alternate or substitute product. Item 9 are what are the technical support capabilities from the supplier. In other words, there's a difference between a person that is an order taker, called a salesperson or sales rep, as opposed to, let's say, a person that not only can take orders from you, but also can give intelligent technical information, and if they can't, they know how to get that information from their own company based upon the type of data you're requiring. Item number 10 is what are the supplier's inventory policies, and you definitely want to know that so that you could establish at some point in time the supplier stocking programs. And in item 11 is the supplier's warranty and service policies. And included in their service policies could also be their repair policies and the lead time of repair. Now, item 12 is, add additional requirements for the development and the training of purchasing personnel that are going to support the maintenance management program. And I have a note here for those of you that are in the purchasing environment. Don't be afraid to ask for assistance within the maintenance organization itself. In many cases, some of the data that I've discussed with you on pages 3 and 4 can be provided by various craft personnel. And I might also make a note here that all of this data is not required for all of the parts that you may need some information on. This is merely a checklist for you to consider relative to the type of data that you're trying to gather for either maintenance personnel, facilities engineering, or operations personnel. Now, moving on to page number 5, we have some additional information relative to spare parts purchasing consideration. And again, all of this data is covered on pages 5 and 6, and there is some additional information. Some of this we may have touched upon in the previous 2 pages, but let's review them and address any of the items that would require additional clarification. I think the part number, the description, the unit of measure, the unit of conversion, the where use code, the inventory classification code, the lead times have all been defined for you in previous sections of this notebook and seminar. But the quantity required and the date required would come from the inventory management program, which is actually precipitated by the maintenance work order planning and scheduling system. So if a requirement is for a planned, let's say, maintenance work order, then 10 is addressing the maintenance work order number to be recorded on the purchase order, and we subsequently want to have the purchase order recorded on the maintenance work order. We also want to consider in item number 11 special quality requirements, which may be the input into receiving inspection or maybe third-party inspection. If there's special packaging required to support the quality of the product while it is in transit, while it is being handled from the vendor to the maintenance storeroom, then those special packaging requirements should be made an integral part of the purchase order. We've addressed the shelf life code previously. This is the responsibility of purchasing to place the shelf life code on the original purchase order so that when that item is received by the storeroom, that shelf life coding analysis can be made intelligently. Again, we have to consider the price and quantity discounts if quantity discounts are applicable. And again, the other information relative to the supplier, which is item number 15, and the supplier part number and the supplier description if it's different from yours, and you definitely need that information in your supplier database. And then as 18 indicates, any warranty information if required. And moving on to page number 6, item number 19, the supplier repair capability and the repair lead time. Also, we want to get the manufacturer's part number if the item is purchased by your supplier, and especially equipment OEMs that are purchasing items from a supply house or directly from the manufacturer itself. You need this for 2 reasons. Reduce your purchase order cost and reduce the lead time to obtain the part. 21 would be shipping instructions, where you are going to utilize special shipping carriers from the supplier to yourself, and also shipping instructions that you would give, let's say, the storeroom, where you are either returning material for credit or replacement, or you are sending material out for outside repair. And then 22 is the current purchase order lead time, and any other information should be added to this list. So what we're looking at is a very comprehensive list of data requirements to enhance the performance of the purchasing activity within the maintenance management program. Now, on page number 7 and 8, we're addressing the purchasing department's responsibility on follow-up by purchasing on all open purchase orders. And again, I want to walk through the different steps with you, because this is one element that is missing from over 80% of all of the companies I've either worked directly for or had people in my various seminars over many, many years. Number 1, it is the responsibility of the purchasing department to follow up on all purchase orders. Number 2, the follow-up should be done by due dates of the purchase order. But importantly, it should be done prior to the actual due date when the item is to be actually received. 3, the purchase orders that are required for maintenance work orders, planned requirements, should be coordinated by purchasing and the maintenance work order planner and scheduler. Number 4, purchase orders that are required for stock replenishment, that is for future unplanned requirements, should be coordinated by purchasing and the inventory management program. And continuing on page number 8, item number 5, all purchase orders should be coordinated by purchasing and the maintenance work order scheduler or inventory management. In other words, this is kind of a summary of the 2 preceding steps. Step number 6, purchasing order rejects and replacement should have the highest priority and may require personal follow-up by purchasing to get a replenishment delivery as soon as possible in order to meet the due dates of both planned and unplanned work orders. And item number 7, purchasing's responsibility for open purchase orders does not end until the purchase order has been completed and all maintenance requirements have been satisfied. In other words, the job is not done until the purchase order is received 100% complete. Now, moving on to the next 2 pages, 9 and 10, we want to talk about a way to assist the maintenance department when we are going to purchase new equipment or a new asset. And here is something that I hardly ever see on purchase orders, that is items on purchase orders when we purchase new equipment or new assets. And let me walk down these items and explain the degree of requirement for you, and you'll see how this will enhance the maintenance management program. The first thing that should go on the purchase order as an item would be the equipment or the asset you're purchasing, let's say the cost of the item and the due date of that particular item. Now, there are other data elements that are required by maintenance to support the maintenance of that equipment or asset. And here I'm indicating by number here what they are, and they should be added as an item number to the purchase order. As an example, do you require installation information? That's item 1. Now, if you do, that would be really item 2 on the purchase order. It's item 1 in the notebook, but it should be item 2 on the purchase order, and that's the way I want you to look at these other additional items on or in the notebook here on pages 9 and 10. They should be identified as item numbers on the purchase order. The reason for that, if you put the same data elements into a request for quotation and you get confirmation from the supplier and he or she has acknowledged your quote, then you have a binding legal contract. And that means that the supplier must furnish you with all of this information prior to payment, and I'll discuss that when we go to page number 10. The second item in the notebook, which could be the third item on the purchase order, would be dismantling and moving information, if any. Number 3 is operational information relative to the equipment. 4, the recommended spare parts required to support the maintenance of the equipment. 5, the recommended PM program. 6 is the recommended minor and major overhaul programs. 7, training of maintenance personnel. 8, training of machine operators. 9, the safety features of the equipment. 10, the warranty and service provisions relative to the equipment and subsequent spare parts. Item 11, other information. Let's address some other information right now before we move to page number 10. How about the spare parts stocking program for the vendor? I think that would be important. What about the selling price of the vendor or your purchase price of those, let's say, recommended spare parts? And how about where we have material that is being procured by, let's say, a foreign country, offshore purchases, where any of the data that we are requesting may come to us in a foreign language. So therefore, we should indicate as an integral part of the purchase order itself, and previously the purchase requisition, that all data must be sent to us in English language. And any other information that is required should be added to the purchase order and previously to the purchase requisition as an item on the requisition and on the purchase order. Now moving to page number 10, you want to put a notation on the purchase order, something similar to what I have on page number 10. And the notation should indicate that payment will not be made unless all the items are received in its entirety on the purchase order. Now, so a supplier doesn't think that you're trying to play games with him or her, what you may also want to indicate is that the monies for the equipment or the asset that you are purchasing, depending on how the payment is to be made, is in a bank, and here's the bank name, the location of the bank, the phone number, here's the bank account, and any other data that would support that that money is available once the supplier fulfills his or her obligation relative to the purchase order. You could see every item that is listed on the previous page, okay? Page number 9 is for the maintenance management organization's benefit. And it is paramount that the purchase order for new equipment or assets addresses those items that are indicative to support that new equipment or asset in the maintenance department program. Now we want to take a look at some of the purchasing applications that are, let's say, integrated with other activities in the maintenance organization. Item number 11 is starting off with receiving validation. First of all, you should have procedures and the systems in place, and the people that are going to be instrumental in supporting these types of receiving validations should be properly trained so that they know exactly how to process one of these receipts when they occur. And let me just walk through these receiving activities with you. First of all, what are your systems and procedures to handle early receipts? Now, you certainly would not want to return the shipment to the supplier at his or her expense, but you may want to receive the item but hold the payment based upon meeting the original scheduled receipt date that was on the purchase order. Likewise, how do you handle over shipments, partial shipments, non-conform packaging, non-conform carrier, or invalid receipts? An invalid receipt is something that you received, let's say the label was correct, but the contents internally was incorrect. That means that maybe your material is at another customer of the supplier. So you could see it's important to establish the procedures and the systems and the proper training to support receiving validation. Now moving on to page number 12, we're addressing some of the issues of receiving inspection. Receiving inspection is becoming more and more an integral part of the maintenance storeroom, but it is really supervised, dotted line from purchasing to the storeroom itself. And again, there may be a need to have procedures and other documentation relative to these various inspection requirements. So let's start off with the first one, where inspected and tested. It could be done internally by you. It could be done by the supplier. Therefore, you would have certified test results from the supplier, or it could be done by a third party. What about the level of inspection? Is it to be done 100%, or are you going to require some AQL, assured quality level, depending upon the lot size and how critical the elements are that are going to be inspected relative to that particular lot size. There could be a sample size that could be tested, which is similar to a level of inspection. Sample testing and analysis could be a key issue. And sometimes in sample testing and analysis could be a destructive test. And that's like the yield factor that we talked about in material planning, where we go lot to lot or order to order requirements. And here, if we recognize a destructive test requirement, we want to add that particular quantity to the lot size that we are purchasing. There may be some need to obtain gauges and equipment, and probably your own internal inspection department, your QC or QA department may support the receiving inspection function within the maintenance storeroom. Then there is the inspection lead time that we addressed earlier, and then any supplier documents that are required for the testing and the validation of testing should also be included on purchase orders and procedures developed in terms of the filing and the ability to retrieve supplier document information. Now, moving on to page 13, we're talking about receiving disposition. We would hope that everything that comes in to the receiving department or receiving section of the storeroom is accepted. But you and I know that at times the supplier may have a problem, and therefore, again, we should have the procedures and the policies established relative to the other items that appear on page 13. As an example, if there's a reject, you may want to return the entire shipment to the supplier. Now, this means that purchasing is going to have to get on the horn and start expediting immediately for a replacement shipment. This again depends upon whether that lot was for a particular planned maintenance work order, or is it for, let's say, replenishment of store's inventory for future unplanned requirements. Maybe there would be a need to rework a few items in order to use it. Who's going to pay for the rework? The supplier should. But before you can, expend any rework cost internally within your own organization, we certainly want to get supplier approval for the rework charges. Likewise, sorting. You may have to sort out a few items in a multi-parts, if you will, shipment. And again, who's going to pay for the sorting? Well, we'd have to follow the same, getting the approval, if you will, from the supplier as rework was addressed. And then if it's scrapped outright, you should really try and get some direction from the supplier whether you may want to scrap it internally within your own operation and give the supplier credit for any, let's say, scrap savings from either materials or whatever, or just scrap it outright with the supplier's written approval. Now, moving on to page number 14, we want to address the shelf life code. We've discussed shelf life code, but here again, it's the responsibility of purchasing to put the shelf life coding on the purchase order. And the shelf life codes are date codes which are established by the manufacturer. In other words, it's an expiration date. The expiration date says, do not use this part if this date has been exceeded. So we have to have the ability to communicate to the receiving function of the maintenance storeroom so that when they get a receipt, they could check the shelf life code, and also to determine, as I mentioned earlier in this seminar, they should be able to calculate the quantity received versus how long will it be in stock relative to the shelf life code. And this can be developed very easily by querying the inventory management program, look at historical usage over a predetermined time period, and try and correlate the inventory on hand based upon the new shipment received and how long it will be on hand relative to the shelf life code. If we're going to have inventory over and above the shelf life expiration date, then we want to return any excess back to the supplier for a more current shelf life coding item. So again, this is the responsibility of purchasing coordinated with the storeroom. Now, moving on to page number 15, we want to talk about the supplier evaluation or performance or appraisal program. And what I have outlined here on page 15 are the key data elements in order of preference as established by many of the companies that I have worked for indirectly or through the seminars that I have conducted in the past. Quality is key. Then secondly is delivery, followed thirdly by quantity. So quality is a byproduct of receiving inspection. Delivery is comparing the date I received it versus the date I wanted it in. And quantity is counting the material in the storeroom at the time of receipt and comparing it to what the packing slip quantity had indicated. Cooperation is generally fixed within an evaluation program unless purchasing has some reason to make the change. Packaging is a function of receiving and receiving inspection. I may indicate on the purchase order the method of packaging and also the transportation. So those two can be reviewed and inputted by the receiving and receiving inspection activities. And price is really the verification of receiving the supplier's, let's say, invoice and comparing that invoice to either the quoted price or the price that we currently have on the purchasing record. Now, this particular supplier evaluation program should be introduced to those suppliers that are going to be an integral part of evaluation. There is a letter of introduction that is required by you to be sent to the Chief Executive Officer of the supplier. You may want to indicate the items as they appear on page number 15, that these are the criteria for evaluation. You may also want to indicate that each quarter or at the end of every quarter we will issue a report card indicating the performance of that supplier to other suppliers and to the objective of the program. And lastly, what we want to do is communicate to the supplier that the intent of the evaluation program is to provide supplier certification. And once the supplier is certified, then that means that you can eliminate the receiving and the receiving activities of that supplier, and that supplier could now support a JIT application in the maintenance work order planning and scheduling system. Now, to get started, if you would turn to page number 16, we are going to use the same data elements that we covered on page number 15, except now we're going to give each element a weighted point average. And in this particular case, we are using what is known as a 100-point average. What we're going to do is we're going to verify each one of these for every receipt from a supplier. If there is a variation from the points as indicated here, which means at the end of a quarter the supplier has not retained a 100-point record, then that means that the supplier is going to have to add on another quarter, okay, and continue on an annual basis until he or she has had 100 points for each quarter during the first year of evaluation. Now let me just give you one indication on how the points are calculated if the supplier does not meet a performance. I'm going to assume during the first quarter we received 10 shipments from the supplier and 1 shipment had a quality problem. That means during that quarter we're going to multiply the 30 points by 9 over 10. In other words, 9/10. 9 shipments were accepted out of 10. Now that in division and in basic math would be 0.9. I would multiply 0.9 by 30, which means that the supplier for that quarter earned 27 points for quality. And this is the same thing you want to go through for each and every item that is on this list. You want to be able to show the supplier by, let's say, supplier number, where he or she is relative to the rest of the suppliers that are an integral part of the performance appraisal program. And with a notation that you want that supplier to succeed. You want that supplier to have 100 points for the first 4 quarters of the first year when this program is being instituted, so that that supplier can be certified. And since you've already done this in your preliminary, let's say, letter of introduction of the performance or appraisal program to the supplier, you're going to find out that these suppliers, and especially the CEO, not the sales manager, not someone in order entry, this has to be accomplished with the CEO's knowledge. There's such a thing as pride of ownership. Now, if you turn to page 17, here we have the benefits of the supplier performance or appraisal program. It establishes for quality control, not receive an inspection, but for quality control of the program, okay, a performance rating system, which is uniform. It highlights and classifies the worst to the best. It also establishes both current and historical data for each supplier. Historical, that is the data that has been generated through the point evaluation over the last quarters. And last but not least, it provides a uniform supplier certification program. And that is really the name of the game. Now, we do have some additional information relative to vendor requirements. And these should really be used when you're going to start the appraisal program, but this should also be used when you're analyzing a new supplier and to determine whether that supplier is going to be an integral part of your supply base. First of all, you want to make certain that the supplier furnishes quality as specified. Secondly, that the selling prices are reasonable, and those you can compare to, let's say, other suppliers of equal or similar type products. Meets your delivery promises, provides the technical assistance that I alluded to before, keeps up to date on technological improvements, which means that as those technological improvements enters that supplier's product or product lines, that you're going to get higher quality, longer longevity items, and hopefully at least cost to you. Settles complaints promptly and fairly, is financially sound, operates on his money, not yours, And by that I mean if a supplier ships way ahead of the required date, that is an indication that maybe the supplier needs some cash, and if you pay those invoices at once, he or she is operating on your money and not theirs, has good labor relations. And let me just indicate something relative to item number 9. If a supplier has a union, you should get a copy of that union contract. That union contract is called, open domain. It's not privy information. The thing you want to do is in that union contract, determine the expiration date of the contract. Then put that into a bring-up file in the purchasing system. Probably 6 months prior to the expiration of the contract would be a good first query into bring-up. And what you're basically doing is contacting the supplier to determine how negotiations are going, if any, and if they anticipate any problems. The clients that have instituted that program have prevented from receiving major stockouts when a key supplier went on strike, had other labor problems, where those clients of mine had the opportunity to get second sources or get inventory in advance from the current supplier, which is over and above the safety stock, but it's protection stock during a particular labor problem relative to the supplier. Has intelligent and helpful sales personnel that I addressed earlier, and also has competent management which carries out complaints to their utmost. Now on page 19 is the procedure for the sale of surplus, scrap, and obsolete materials. I've identified those earlier, but I'd like to just walk you through them to at least for you to get a feel for this, and you actually should have your disposition policies and procedures in line, and hopefully this particular exhibit with the items on here would support your particular program. Number 1 are the materials for disposal sold by the buyers responsible for new materials of the same category. In other words, if you have 2 or more personnel in purchasing, do they know the disposition of that particular material that is being disposed of? Again, easiest way to eliminate future problems is go through a bonded scrap dealer. Are the available markets and channels of distribution known and constantly reviewed? In other words, there may be a need to save high cost alloys, and then as the market has an upswing, to sell that scrap and surplus to get the highest return on scrap and surplus dollars. 3 are usable or reclaimed materials disposed of such rather than as scrap. In other words, can you cannibalize materials that may be destined for the scrap yard? Is there a possibility of using an item as a substitute? Or can you sell those if they are commonly used items and available on the open market at a percentage of, let's say, a cost of $1? And item number 4 are second-hand dealers, known as opposed to scrap dealers. Don't sell anything to a second-hand dealer. The material is going to wind up somewhere in the marketplace in the near future. 5 are materials properly sorted or segregated. And this has to do especially with the selling of high dollar, let's say, cost alloys. If you mix it, you get the lowest cost. If you keep them separate, you get the highest cost. And 6 are functions in the scrap markets watched and taken advantage of. And those could be scrap reports and other types of reports that are an integral part of the scrap processing industry. And 7 are disposal procedures such as to avoid loss of value to deterioration in storage. In other words, if you have items that could possibly corrode, they could downgrade the scrap value, and therefore you're going to lose scrap income. 8 are trade practices among scrap dealers known. And there are different scrap dealer associations, and if you have enough of this type of material going out through the scrap in surplus process, you may want to find out about those associations and get on their mailing lists. And 9, should material be disposed of or reclaimed and used? Well, again, we have to be very careful in terms of the type of material we're talking about, and which really addresses item number 10, and are all of the OSHA rules and regulations known and followed? And is there any EPA or any of your own, let's say, insurance carrier rules and policies documented and known? These are some of the critical elements relative to the sale of scrap and surplus. The last 2 pages in this section addresses the purchasing vendor programs. That is, the programs between you and your supplier.